Okay, problem 717. If f is differentiable and we have this, the limit when x goes to 0 of f to the 2x cubed over 5x cubed equals 1, and its derivative f prime is continuous at 0, calculate f at 0, right? Well, the first part is easy. We have done this before. The limit when x goes to 0 of f of 2x cubed divided by 5x cubed, right? This thing is going to 0, right? And so if we want the limit to be 1, then this thing has to go to 0, which means the limit when x goes to 0 of f, and then the argument is going to be 0 because f is continuous. The limit when x goes to 0 of f of x is going to be equal to f at 0. This has to be 0 in order for this limit to be able to be something that's different than infinity. Okay? Now, for part B, calculate f prime. Well, if this is going to be 0 over 0, then the limit of the derivatives is going to be, and then we have the derivative of this is f prime at 2x cubed times the derivative of this, which is 6x squared, divided by 15x squared. Okay? And this is going to be the same when we take the limit of this is f prime at 0 times, and then we can divide here, take common factor 2, 5. This is equal to 1. Okay, this is what we want. So f prime at 0 is going to be 5 divided by 2. Okay? And then for the last part, we have the limit when x goes to 0 of f composed with f at 2x, and then we have the inverse of f at 3x, right? Now the limit, we know that f at 0 is 0. This limit, if f at 0 is 0, then this implies we take the inverse in both sides, that the inverse of 0 is going to be 0, right? You think about what that inverse is. If f crosses the origin, then the inverse also crosses the origin, right? So that means this is an indetermination, and in order to 0 over 0 indetermination, in order to compute it, we need to apply L'Hopital's theorem. Right? So this is the limit when x goes to 0, and then so this is the derivative of the first thing, and then applying the chain rule, we need to apply that this is the derivative of the second thing, right? But then we have the derivative of this, so times 2, divided by, and then we have the derivative of the inverse, which is 1 divided by f prime at f minus 1 of 3x, right? And then the derivative of this, which is 3. So this is 2/3, and then we take the limit here, right? So this is f prime at 0 times f prime at 0, and then this passes multiplication, multiplying above, so this is f prime at 0 cube times 2/3, but f prime at 0 is 5 over 2, so this is 5 cube, which is 125, times 2 times 3 times 2 cube, which is 8, right? So this and this go away, so we have 125 divided by 12, and this is the value of that limit.